By all laws of Euclidean geometry, thermodynamic probability, and sheer mathematical scale, you should not be experiencing darkness. The temperature of the void between galaxies hovers at a suffocatingly cold 2.7 Kelvin above absolute zero. It is an ocean of frost, a sensory deprivation chamber expanding into a seemingly infinite horizon. Yet if the cosmos is truly infinite, timeless and uniformly populated by luminous matter, every single line of sight you cast outward into the heavens must inevitably terminate on the surface of a star. Think of it like standing deep within a vast, endless forest. No matter which direction you look, your line of sight will eventually hit the trunk of a tree. In an infinite universe, the stars are those trees. There should be no empty spaces, no black patches between the constellations. The entire dome of the sky, day and night, should be a blinding, seamless wall of plasma, radiating with the exact intensity of the surface of our sun. Under these strict mathematical conditions, the oceans of Earth would flash boil into steam within seconds. The atmosphere would strip away in a torrent of fire, and the very crust of the planet would melt into glowing slag under the unbearable weight of infinite, inescapable starlight. The fact that you can step outside in the dead of night, stand in the quiet, freezing air, and see a stark black expanse punctuated only by isolated pinpricks of pale light is a profound violation of intuitive physics. It is a glaring anomaly, hiding in plain sight. For centuries, the greatest minds in astronomy wrestled with this terrifying contradiction. They mapped the celestial spheres, calculated the velocity of photons, and ground perfectly curved lenses to peer deeper into the abyss, only to find the same haunting emptiness staring back. The mathematics demanded a sky of blinding, overwhelming fire. Reality offered only a silent, frozen void. This discrepancy is not merely a quirk of human perception, nor is it a trick of interstellar dust blocking the light. Dust would simply heat up and glow just as intensely over infinite time. Instead, this dark sky is a fundamental glitch in the assumed architecture of reality. It is a paradox that whispers a devastating truth about the origins, the mechanical limits, and the ultimate, inevitable death of everything that exists. To understand why the dark exists is to unravel the very fabric of time and distance. It requires abandoning the comfort of common sense and descending into the cold, unforgiving machinery of cosmic expansion. We must explore a reality where light itself behaves like data, traveling across a vast, lagging network, fighting a losing battle against the aggressive stretching of the void. We will dissect the absolute boundaries of the visible universe, trace the physical exhaustion of ancient radiation, and look directly into the mathematical blind spot of existence. If you seek the brutal truth hidden within the dark and demand a deeper, uncompromising understanding of the mechanics of our universe, subscribe and join us on this journey. We will not offer you comfortable illusions, only the profound reality of the cosmos. The investigation into this cosmic silence begins not with modern orbital telescopes or massive digital sensors, but with the fragile limitations of the human mind and a fatal miscalculation regarding what it actually means to look back through the corridors of deep time. Human perception is a biological lie, optimized for hunting and gathering on the sunlit plains of a rocky world, not for parsing the crushing mechanics of the cosmos. When you stand under the night sky and look up, your brain processes the incoming photons as an instantaneous event. You see the star Sirius, and your intuition tells you that you are seeing Sirius exactly as it is in this precise moment. This is a cognitive illusion. You are not looking at the universe, you are looking at a delayed transmission, an archival record written in decaying light. The photons hitting your retina have been crawling across the absolute zero vacuum of space for years, centuries, or millennia. Because light travels at a finite speed, every time you look up, you are looking backward in time. The sky is not a spatial map. It is a temporal graveyard. To comprehend the terrifying depth of the paradox we face, we must first unlearn the physical intuition that humanity clung to for thousands of years. For the vast majority of our history, the universe was a safe, manageable construct. Under the ancient Aristotelian and Ptolemaic models, the Earth sat motionless at the center of reality, encased by a series of nested, transparent, crystalline spheres. The stars were nothing more than brilliant points of light, physically embedded in the outermost shell. It was a closed system, a cosmic terrarium. In this model, the darkness of the night sky made perfect logical sense. Beyond the final sphere of stars, there was simply nothing. No space, no time, just a philosophical void. There was no paradox because the universe had a solid, physical wall. This comforting architecture was violently dismantled in the late 16th century. An English astronomer and mathematician named Thomas Digges took the revolutionary heliocentric model proposed by Copernicus and pushed it to its terrifying logical conclusion. Digges shattered the outer crystalline sphere. He took the stars, which had been safely pinned to a ceiling, and scattered them outward into an infinite, boundless expanse. It was a moment of profound philosophical liberation, breaking humanity out of its enclosed box. But this intellectual freedom triggered a mechanical nightmare that the greatest minds of the era were completely unprepared to handle. Johannes Kepler, the brilliant German mathematician who would later unlock the laws of planetary motion, looked at Digges's infinite universe and recoiled in horror. Kepler possessed a mind that demanded mechanical precision and rigorous geometric harmony. He understood intuitively what others had missed. You cannot simply declare the cosmos to be infinite without triggering catastrophic mathematical consequences. In 1610, Kepler formulated the first iteration of the dark sky problem. He realized that if the universe goes on forever and is populated by an infinite number of stars, then no matter where you look, your line of sight must eventually intersect with the surface of a star. There should be no dark gaps. The sky should be a solid, unbroken wall of blinding starlight. Because we clearly observe a dark sky, Kepler argued, the universe cannot be infinite. It must have an absolute edge. He chose the claustrophobic safety of a finite, walled universe over the blazing terror of infinity. Yet, as the centuries progressed, the concept of a static, infinite universe became the bedrock of scientific consensus, largely driven by the monumental weight of Isaac Newton's physics. Newton's laws of universal gravitation posed a fatal problem for a finite universe. Gravity is an exclusively attractive force. If the cosmos had an edge and contained a finite amount of matter, the collective gravitational pull of every star would eventually drag all matter toward the center. The universe would inevitably collapse in on itself in a catastrophic crunch of unimaginable density. To prevent this gravitational suicide, Newton reasoned that the universe must be infinitely large, populated by an infinite distribution of stars pulling on each other equally from all directions. This infinite tension would hold the cosmos in a delicate, eternal equilibrium. But by mathematically saving the universe from gravitational collapse, Newton inadvertently resurrected Kepler's nightmare. The infinite universe was back, and with it, the inescapable mandate of a blazing, lethal sky. To truly grasp the mathematical violence of this paradox, we must dissect the specific mechanics of how light propagates through a vacuum. It is governed by a cold, merciless equation known as the inverse square law. Imagine standing alone in a dark field, a few meters away from a massive, roaring bonfire. You feel the blistering heat against your skin, and the light is blinding. Now step back until you are exactly twice as far away. Your intuition might suggest the light and heat will drop by half. But the physical universe does not care about intuition. As the light from the fire travels outward, it is forced to spread across a spherical area that grows exponentially. At twice the distance, that sphere is 4 times larger. Therefore, the intensity of the light you receive is violently diluted, dropping not to a half but to 1/4. If you step back to 3 times the distance, the light spreads across an area 9 times larger, dropping the intensity to a mere 1/9. The energy decays exponentially, fading into a fragile whisper of photons as it crosses the void. At first glance, the inverse square law appears to be the perfect mechanism to save us from the blazing sky. It provides a highly intuitive escape hatch. Surely the stars that lie millions of light years away are simply too distant, their light mathematically crushed and diluted by the sheer volume of space until it is completely undetectable by the human eye. This is the assumption most people make when faced with the dark sky. But it is a catastrophic failure of logic, a severe underestimation of the power of infinity. Imagine drawing a massive invisible sphere around the Earth, forming a hollow shell in space. Now imagine another shell exactly like it, but located twice as far away. According to the merciless arithmetic of the inverse square law, any individual star inside that second, distant shell will appear exactly 4 times dimmer to an observer on Earth than a star in the first shell. But here is the fatal mathematical trap. Because that second shell is twice as far away, its total volume is precisely 4 times larger. If stars are distributed evenly throughout the cosmos, that distant shell contains exactly 4 times as many stars. The equations cancel each other out with terrifying precision. The stars are 4 times dimmer, but there are 4 times as many of them. The total aggregate amount of light raining down on Earth from the distant shell is absolutely identical to the total amount of light from the closer shell. If you extend this logic outward, drawing shell after shell into an infinite expanse, the mathematics offer no mercy. A shell 10 times further away has stars 100 times dimmer, but it contains 100 times as many stars. A shell 1,000 times further away has stars 1,000,000 times dimmer, but it holds 1,000,000 times more blazing furnaces. The aggregate light contribution from every single shell is exactly the same, and in an infinite universe, there are an infinite number of these shells. You are adding the same quantity of light to the Earth an infinite number of times. The mathematical sum of this equation is not a quiet, dark night. The sum is infinite heat, infinite radiation, a sky that burns with the intensity of the core of a star, annihilating any possibility of solid matter, let alone biological life. The scientists of the 18th century found themselves trapped in a mathematical prison of their own making. Edmund Halley, the legendary astronomer who plotted the orbit of his namesake comet, attempted to use early calculus to prove that the light from distant stars would eventually taper off into insignificance. His calculations were desperate, and ultimately, his geometric assumptions were flawed. The math refused to yield. In 1744, a Swiss astronomer named Jean-Philippe de Chézeaux proposed a brilliant physical solution to the paradox. Chézeaux accepted the terrifying geometry of the infinite shells, but he introduced a physical barrier within the void itself. He hypothesized that the space between the stars was not perfectly empty. He proposed that the cosmos was filled with a tenuous interstellar medium, a thin, invisible fog of cosmic dust and gas. As the light from the infinite depths of space traveled toward Earth, this cosmic fog would gradually absorb the photons, dimming the light of the most distant stars before it could ever reach us. It was an elegant, highly intuitive theory. It is the exact same principle as driving a car through a heavy, freezing fog in the middle of the night. The headlights of distant vehicles are completely swallowed by the mist. You can only see the faint glow of the cars immediately surrounding you. Chézeaux believed this interstellar fog acted as a shield, protecting the Earth from the lethal radiation of infinity. But Chézeaux lived in an era before the brutal laws of thermodynamics were fully understood. His elegant solution harbored a fatal, physics-destroying blind spot. In an infinite, eternal universe, energy cannot simply vanish. It must go somewhere. If an infinite expanse of cosmic dust is continuously absorbing an infinite amount of radiation from an infinite number of stars, that dust cannot remain cold. It will begin to absorb the kinetic energy of the photons. Over millions, billions, and trillions of years, the dust will inevitably heat up. It will continue to absorb energy until it reaches a state of thermodynamic equilibrium with the stars themselves. At that point, the interstellar fog will become so unimaginably hot that it will begin to radiate light. The dust itself will ignite. It will glow with the exact same blinding intensity as the surface of the stars it was supposed to obscure. The protective shield becomes a furnace. The night sky burns exactly the same. It was not until 1823 that a German physician and amateur astronomer named Heinrich Olbers formalized this terrifying contradiction so clearly and devastatingly that it became known forever as Olbers' paradox. Olbers stripped away the faulty geometry of Halley and the thermodynamic failures of Chézeaux. He laid bare the stark, unforgiving parameters of the universe as science understood it at the time. A universe that was infinite in scale, eternal in age, completely static in its architecture, and uniformly populated by blazing suns. Under these strict, accepted conditions, a dark night sky is mathematically and physically impossible. Olbers looked up at the quiet black expanse above him and realized he was not looking at a peaceful void. He was looking at a screaming anomaly. The darkness was an active violation of the laws of physics. It meant that human intuition and centuries of established astronomical dogma were fundamentally and violently wrong. If the sky is dark, then one of the absolute pillars of reality must be cracked. The universe cannot be infinitely large, or it cannot be eternally old, or it cannot be perfectly static. Something in the machinery of the cosmos was broken, or perhaps functioning in a way that defied the limits of human imagination. The failure of generations of scientists was not a failure of their mathematics, nor was it a defect in the lenses of their telescopes. Their fatal error was not a misunderstanding of space, but a profound, catastrophic misunderstanding of time. They viewed the cosmos as an eternal, unchanging stage, a static theater where stars burned indefinitely in the dark. But the universe is not a museum. It is an engine. And to comprehend the true nature of the darkness, we must abandon the rigid geometry of fixed stars and descend into a far more disturbing reality. We must look at the physical degradation of light itself as it is stretched and broken by the mechanics of a cosmos that is actively trying to pull itself apart. To dismantle the paradox, we must first confront the terrifying reality of the speed of light. For most of human history, light was assumed to be instantaneous, a divine phenomenon that connected the observer to the observed without delay. But the universe is a machine bound by strict, unbreakable limits. In the late 17th century, a Danish astronomer named Ole Rømer spent years staring through primitive glass lenses at the violent storm-ravaged system of Jupiter. He was meticulously timing the eclipses of its innermost moon, Io, as it vanished behind the massive gas giant. Rømer noticed a chilling discrepancy. When the Earth in its orbit was moving closer to Jupiter, the eclipses occurred earlier than predicted. When the Earth was retreating, moving further away into the dark, the eclipses were delayed. The mechanics of the celestial clockwork were not failing. The delay was the physical travel time of the visual data. Rømer had captured the ghost in the machine. He proved that light is not an instantaneous event, but a physical entity, a messenger dragging itself across the vacuum at a finite, measurable velocity. 300,000 kilometers per second. It is a speed so violently fast that it defies human comprehension. Yet on the cosmic scale, it is agonizingly, paralyzingly slow. It is the absolute speed limit of causality. Nothing, no force, no information, no gravitational ripple can propagate through the fabric of reality faster than this exact limit. And this finite speed is the key that unlocks the first gate of the dark sky paradox. Because light requires time to cross the void, a profound and disturbing truth emerges. The universe acts as the ultimate time machine, but it only runs in reverse. When you look at the moon, you do not see it as it is. You see it as it was 1.3 seconds ago. You are looking at a phantom. When you look at the sun, you are feeling the warmth of a fire that burned exactly 8 minutes and 20 seconds in the past. If the sun were to violently detonate this very instant, the Earth would continue to orbit a ghost, bathed in bright warm light for 8 terrifying minutes before the final annihilating shockwave of darkness arrived. As we cast our gaze deeper into the cosmos, the lag in the system becomes catastrophic. The light from the nearest star system, Alpha Centauri, takes over 4 years to cross the interstellar desert. The soft glow of the Andromeda Galaxy, the closest galactic neighbor to our Milky Way, is an image 2.5 million years out of date. The photons striking your retina tonight began their journey before the human species even existed. This inescapable lag shatters the premise of Heinrich Olbers's mathematical nightmare. Olbers assumed a universe that was infinite, not only in space but eternal in time. But in the mid-19th century, an American poet and writer of Gothic horror, Edgar Allan Poe, of all people, stumbled upon the mechanical solution in a feverish essay titled Eureka. Long before the mathematical models of modern cosmology were established, Poe reasoned that if the universe had a definitive beginning, a moment of creation, then the age of the cosmos was finite. If the universe is not infinitely old, then light has only had a limited amount of time to travel. Modern astrophysics has violently confirmed Poe's intuition, pinning the age of the universe at roughly 13.8 billion years. This number is not merely a historical trivia fact, it is a physical wall, a hard, uncompromising boundary known as the cosmological horizon. We can only see objects whose light has had enough time to reach us since the dawn of creation. If a star exists 50 billion light-years away, its light is still traveling. It is out there, moving silently through the deep freeze of the vacuum, but it has not yet arrived. Our visible universe is a finite bubble, expanding outward at the speed of light, containing a limited, quantifiable number of stars. The sky is dark primarily because the vast majority of the universe's light is simply still in transit. We are surrounded by a crushing, infinite expanse of blazing radiation that is rushing toward us, but has not yet hit our senses. We are sitting in the dark, waiting for the flash. But this is only a partial victory over the paradox. It explains why the sky is not an infinite wall of fire, but it does not fully explain the profound, hollow emptiness we observe between the stars. If we accept that our view is limited to a bubble of finite age, we must then ask, what exactly is inside that bubble? Is the dark space between the visible stars truly empty, or is human biology simply too weak to see what is hiding there? To answer this, science had to abandon the fragile human eye and build a mechanical proxy capable of staring into the absolute abyss without blinking. In December of 1995, the director of the Space Telescope Science Institute made a decision that many of his colleagues considered deeply reckless. He took the Hubble Space Telescope, a billion-dollar orbital observatory, and pointed it at the most unremarkable, utterly empty patch of the night sky he could find, a microscopic region near the constellation Ursa Major. To the naked eye, and even to ground-based telescopes, there was absolutely nothing there. No stars, no known galaxies, just the cold, dead blackness of the void. The patch of sky was roughly the size of a grain of sand held at arm's length. For 10 consecutive days, the Hubble telescope maintained an absolute motionless lock on this microscopic void. It was an exercise in extreme mechanical endurance. The telescope completed 342 orbits around the Earth, meticulously opening its sensors to capture whatever stray photons might wander out of the deep dark. This was not photography as we understand it. It was the painstaking accumulation of isolated particles of light, some of which had been traveling undisturbed for over 10 billion years, only to end their cosmic journey by colliding with a silicon-charged coupled device in low Earth orbit. The digital sensors operated in the freezing vacuum, suppressing the thermal noise of their own electronics, registering the fainter-than-faint impacts of ancient radiation. When the data was finally compiled, translated from raw binary code into a visual image, the resulting photograph completely shattered our understanding of the void. The Hubble Deep Field did not reveal an empty blackness. It revealed a terrifying, suffocating density of matter. Within that single microscopic grain of sand held against the night sky, the telescope found over 3,000 entirely distinct galaxies. Not stars, galaxies. Massive swirling archipelagos of matter, each containing hundreds of billions of blazing thermonuclear engines. They were scattered across the darkness in a chaotic, luminous spray, stretching back to the very dawn of the cosmos. Some were violent spirals of blue-hot young stars, others were massive, dying elliptical galaxies glowing with the dull red heat of ancient iron. The implications of this image are mathematically staggering. If you take that single grain of sand and extrapolate it across the entire 360-degree dome of the sky, the true scale of the observable universe snaps into focus. There are an estimated 2 trillion galaxies packed into our visible bubble. 2 trillion massive cosmic structures containing a number of individual stars that eclipses the number of grains of sand on every beach on Earth by orders of magnitude. The void is not empty. The universe is terrifyingly crowded. Every single millimeter of the dark night sky is absolutely saturated with the blazing light of trillions of distant suns. And yet, when you step outside and look up, The sky remains black. The Hubble Deep Field proved that the light is there. The photons are arriving. The energy is raining down upon us in unimaginable quantities. The paradox of the dark sky has returned, more aggressive and inexplicable than before. If the sky is literally painted entirely with galaxies, why do our eyes see nothing but the void? To understand the mechanics of this vanishing act, we must look at a physical phenomenon discovered in the frozen mountains of Arizona in the early 20th century. Vesto Slipher, an astronomer working in the freezing dome of the Lowell Observatory, was spending his nights pushing the physical limits of early spectrography. He was taking the faint light from distant spiral nebulae, passing it through a prism, and splitting it into its constituent colors. This technique reveals the chemical barcode of a galaxy. Different chemical elements in the burning atmospheres of stars absorb specific frequencies of light, leaving dark vertical lines across the rainbow spectrum. Slipher was looking for these lines to determine what the distant nebulae were made of. But as he painstakingly analyzed the photographic plates, he noticed an impossible anomaly. The dark chemical barcodes were not where they were supposed to be. They were completely wrong. The lines were systematically shifted out of their natural positions, pushed violently toward the red end of the spectrum. Slipher had captured the cosmic equivalent of a screaming siren passing you on the highway. When an ambulance speeds toward you, the sound waves are mechanically compressed, driving the pitch higher. As it speeds away, the sound waves are stretched, and the pitch drops to a lower, deeper moan. This is the Doppler effect. Slipher realized that light behaves exactly the same way. If a light source is rushing toward you, its light waves are compressed, shifting the color toward the blue end of the spectrum. If a light source is fleeing from you, the light waves are stretched, elongating the physical distance between the peaks and valleys of the wave, shifting the color toward the red. Almost every single galaxy Slipher observed was heavily red-shifted. They were not just moving, they were fleeing. A decade later, Edwin Hubble took Slipher's disturbing data and combined it with his own measurements of distance. Hubble mapped the redshift of dozens of galaxies against their physical distance from Earth, and he uncovered a mathematical relationship that destroyed the concept of a static universe forever. Hubble discovered that the further away a galaxy was, the faster it was moving away from us. The relationship was linear, merciless, and absolute. A galaxy twice as far away was receding twice as fast. A galaxy 10 times further away was fleeing 10 times faster. The galaxies were not moving through space. Space itself was expanding. The very fabric of the vacuum, the unseen grid of reality, was swelling, dragging the galaxies along with it, like dots drawn on the surface of an inflating balloon. This is the brutal physical mechanism that finally executes the light. When a photon is emitted from a distant galaxy, it begins its journey across the void. But as it travels, the space it is moving through is actively expanding beneath it. The photon is caught on a moving treadmill, and because light is a wave as the space stretches, the wave is physically stretched along with it. This is not a trick of perception. It is a violent thermodynamic reality. The physical wavelength of the light is pulled apart, forced to become longer and longer. As a wavelength of light stretches, its frequency drops. As its frequency drops, its physical energy plummets. The light from the most distant galaxies in the Hubble Deep Field began its journey billions of years ago as blinding, high-energy ultraviolet radiation. But as it clawed its way across the expanding universe, the fabric of space ruthlessly stretched it out. By the time it finally reaches our solar system, the light has been stretched so severely that it has completely fallen out of the visible spectrum. It has been shifted past red, plunging into the deep infrared. Human biology is entirely blind to this radiation. Our eyes evolved to detect a microscopic sliver of the electromagnetic spectrum, a narrow band of frequencies that easily penetrates the Earth's atmosphere and is abundantly produced by our local sun. We cannot see the violently stretched light of the deep cosmos. The sky is completely illuminated, saturated with the blazing fires of 2 trillion galaxies, but the physical expansion of the universe has muted the light, stretching it into a cold, invisible phantom. But the expansion of space hides a far more terrifying consequence than mere invisibility. We are standing on a planet, looking out at a universe that is stretching itself into the dark. And as we look at the absolute edge of the observable cosmos, where the expansion becomes impossibly violent, we encounter a boundary where the laws of physics begin to actively tear themselves apart, and light itself faces a mathematical impossibility. Albert Einstein's theory of special relativity established the ultimate unbreakable law of the cosmos. Nothing can move through space faster than the speed of light. It is the absolute speed limit for any physical object, any particle of matter, and any transmission of information. If you attempt to accelerate an object toward this limit, its mass exponentially increases, requiring an infinite amount of energy to push it over the threshold. It is a mathematical barricade that completely locks down the physical universe. But Einstein's later work, the theory of general relativity, contained a terrifying mathematical loophole. The speed of light dictates how fast things can move through space. But space itself is not an object. It is the medium. It is the invisible grid upon which reality is plotted. And the expansion of the grid itself is not bound by the speed limit of the matter trapped within it. Space can stretch, warp, and multiply at velocities that violently exceed the speed of light, and this geometric loophole is actively tearing the visible universe apart. To grasp the mechanics of this barrier, you must visualize the expansion not as an explosion moving outward from a central point, but as a continuous, silent swelling of the vacuum between all things. Imagine a vast, infinitely long rubber sheet pulled taut in all directions, with galaxies painted onto its surface. If you grab the edges of this sheet and stretch it uniformly, the painted galaxies do not physically move across the rubber. They remain stationary in their local coordinates, but the physical distance between any two galaxies steadily increases. Now observe the mathematics of this stretching. If every segment of the rubber sheet expands by a tiny fraction every second, the total speed of separation between 2 points is cumulative. The further apart two galaxies are, the more expanding rubber exists between them, and therefore, the faster they appear to recede from one another. Astronomers measure this terrifying geometry, using a value that dictates how fast a distant object recedes based on the sheer volume of space sitting between us and it. For every megaparsec of distance, roughly 3.25 million light-years, the expansion of the vacuum adds roughly 70 kilometers per second to the speed at which a galaxy is fleeing from Earth. At a distance of 100 megaparsecs, the galaxy is receding at 7,000 kilometers per second. The mathematics are linear, compounding, and completely merciless. If you simply extrapolate this equation outward into the deep cosmos, you inevitably hit a mathematical wall. At a specific, calculable distance of approximately 14.4 billion light-years from Earth, the cumulative amount of expanding space becomes so vast that the total rate of expansion finally crests 300,000 kilometers per second. This invisible boundary is known as the Hubble sphere. Beyond this exact perimeter, the fabric of the universe is multiplying so rapidly that the galaxies embedded within it are receding from us faster than the speed of light. They are not violating special relativity. They are practically sitting still in their own local pockets of the vacuum. But the ocean of space between us and them is swelling at a superluminal rate. This creates a paradox that breaks the human understanding of cause and effect. Imagine a blazing quasar situated beyond the Hubble sphere. Right now, at this exact moment, it fires a photon of light directly toward Earth. The photon begins its journey, traveling at the absolute maximum speed allowed by reality. It is swimming as fast as the laws of physics permit. But the space it is traveling through is expanding in the opposite direction faster than the photon can move. The photon is rushing toward us at the speed of light, and yet mathematically, the physical distance between the photon and the Earth is increasing with every passing second. It is a runner trapped on a treadmill that is moving backward faster than they can sprint. The light is fighting a mathematically unwinnable war against the vacuum. For decades, astrophysicists assumed that this terrifying expansion was merely the fading echo of the Big Bang. They believed the universe was coasting on residual momentum. Because gravity is an exclusively attractive force, the collective mass of 2 trillion galaxies, the dark matter halos, and the infinite web of cosmic dust should act as a massive braking system. The gravity of the cosmos should be actively pulling backward against the expansion, slowly crushing the momentum, decelerating the growth of the vacuum. It was assumed that the expansion was slowing down. In 1998, two independent teams of astronomers set out to measure this deceleration. They used the Hubble Space Telescope and powerful ground-based observatories to hunt for a very specific cataclysmic event, the detonation of Type 1a supernovae. These are the explosive deaths of white dwarf stars that have consumed too much mass from a binary companion. Because these specific explosions occur at a precise, mathematically predictable threshold of mass, they detonate with an almost identical baseline of intrinsic brightness. They are the standard candles of the universe. By measuring exactly how faint these explosions appear from Earth, astronomers can calculate their precise physical distance. By measuring how severely their light has been redshifted by the stretching of space, they can calculate exactly how fast the universe was expanding when the star detonated billions of years ago. The teams plotted the data on a graph, expecting to see the mathematical curve of a decelerating cosmos. They expected to see the brakes being applied. Instead, the data yielded a result so fundamentally absurd that many physicists initially assumed their instruments were broken. The curve was bending the wrong way. The expansion of the universe was not slowing down. It was actively, aggressively speeding up. Something invisible, undetectable, and unimaginably powerful was operating in the deep vacuum, overpowering the combined gravitational pull of all the matter in the entire universe. It was stepping on the accelerator. Physicists called it dark energy. It is not a substance, nor is it a conventional force. It is a placeholder name for a profound, terrifying ignorance. We do not know what it is. We do not know where it comes from. But the mathematics dictate that it makes up roughly 68% of the total energy density of the entire universe. Dark energy appears to be an intrinsic property of space itself. It is a repulsive pressure built into the very geometry of the void, and this creates a catastrophic feedback loop. As the universe expands, it creates more empty space. Because dark energy is a property of empty space, more space means more dark energy. The repulsive force multiplies, pushing the universe to expand even faster, which in turn creates even more space, spawning even more dark energy. It is an exponential runaway reaction that is steadily tearing the architecture of reality apart. When theoretical physicists attempt to explain the mechanics of dark energy, they hit a barrier of mathematical failure that is considered the greatest embarrassment in the history of modern science. To understand the pressure of the vacuum, physicists turn to quantum mechanics. Quantum field theory dictates that perfectly empty space is not actually empty. It is a boiling, chaotic sea of virtual particles that constantly pop into existence, annihilate each other, and vanish back into the quantum foam in fractions of a microsecond. This boiling activity gives the vacuum an inherent baseline energy. Physicists calculated the expected density of this quantum vacuum energy, seeking to explain the driving force behind dark energy. They completed the equations and arrived at a number. They then looked at the actual observed rate of the universe's accelerated expansion, calculated by the supernova data, to see if the numbers matched. They did not. The theoretical calculation from quantum mechanics was larger than the actual observed reality by a factor of 10 to the power of 120. That is a 1 followed by 120 zeros. It is a discrepancy so colossal that the human mind has no framework to comprehend it. It means our two most rigorously tested pillars of reality, the quantum mechanics of the microscopic world and the general relativity of the cosmic scale, are locked in a fatal, irreconcilable contradiction. When we try to understand the very force that is darkening our sky, our physics fundamentally breaks, and the fracture is only widening. Today, cosmology is actively tearing itself apart over an anomaly known as the Hubble tension. As our instruments have grown more precise, we have developed two highly accurate methods for measuring the exact speed of the universe's expansion. The first method looks back to the very dawn of time, observing the cosmic microwave background radiation, the lingering thermal afterglow of the Big Bang itself. By measuring the microscopic temperature fluctuations in this ancient radiation, physicists can calculate the exact physics of the early universe and project the expected rate of expansion forward to the present day. The second method uses the late universe, looking at the modern standard candles, the pulsing Cepheid variable stars, and the supernovae in our relatively local cosmic neighborhood to measure the expansion happening right now. Both methods are backed by decades of peer-reviewed data. Both methods rely on physics that have been verified with excruciating precision. But when you compare the two numbers, they refuse to align. The early universe calculation predicts a slower expansion rate. The late universe observation measures a significantly faster one. The error bars do not overlap. The margin of error has been completely eliminated. The data is telling us that our fundamental model of the universe is missing a massive, critical piece of machinery. The cosmos is expanding faster than our absolute best laws of physics say it should be. This terrifying acceleration forces us to confront the true physical nature of the dark night sky. The darkness is not just the stretching of ancient light into invisible infrared frequencies. The darkness is an active, aggressive deletion of reality. Because the expansion of the universe is accelerating, the Hubble sphere, the boundary where space begins to recede faster than light, is not static. The superluminal barrier is moving. As dark energy pumps more repulsive pressure into the void, the exact distance at which space exceeds the speed of light is being pulled closer and closer to Earth. The cosmological event horizon is actively shrinking around us. Imagine you are standing on an island in the middle of a vast, dark ocean. You have a flashlight that can illuminate objects up to a mile away, but the water itself is moving, flowing outward in all directions, carrying objects away from you, and the flow is accelerating. A boat that was half a mile away yesterday is now 3/4 of a mile away. Soon the ocean will carry that boat past the 1-mile mark. It will slip beyond the physical reach of your light. Even if the boat has its own massive floodlight pointed directly back at you, if the water is carrying the boat backward faster than the light can travel forward, you will never see it again. It has crossed an absolute horizon. It has been permanently severed from your reality. This is exactly what dark energy is doing to the cosmos. When we point the Hubble or James Webb telescopes into the deep dark, we see the ancient, ghostly light of galaxies that are 10, 12, or 13 billion light-years away. We see them exactly as they were when that light began its journey. But those galaxies are no longer there. Over the billions of years that the light was traveling toward us, the expanding space has carried those physical galaxies far beyond the cosmological event horizon. They are currently sitting in a region of space that is receding from us much faster than 300,000 kilometers per second. This means that the light those galaxies are emitting at this exact second will never, under any circumstances, reach the Earth. Even if the universe exists for another trillion years, even if you possessed a spacecraft capable of traveling at 99.9% the speed of light, you could chase those galaxies for eternity and you would never close the gap. The space between you and them is multiplying faster than you can ever traverse it. The bridge is burned. The mathematical connection has been permanently severed. Every single time you look up at the black sky, you are staring at a zone of absolute causal isolation. The darkness between the stars is the visual manifestation of space expanding faster than the speed of information. It is the void left behind as the universe actively outruns its own light. And the mathematics of this isolation are relentless. Calculate the sheer volume of space sitting on the edge of the event horizon and factor in the accelerating rate of dark energy. The math reveals a chilling reality. Every single second that ticks by, thousands upon thousands of stars are pushed over the edge of the superluminal barrier. Every second, entire galaxies, teeming with billions of thermonuclear furnaces and potentially countless worlds, slip permanently out of our observable universe. They fall over the edge of reality faster than the speed of light, vanishing into a mathematically unreachable abyss. We are not merely standing in a dark forest. We are standing on a shrinking island of light, surrounded by a cosmic tide that is systematically washing away the rest of the universe. The night sky is dark because the cosmos is evaporating into the void, driven by an invisible, incomprehensible force that is methodically isolating every structure. severing the physical chains of gravity and light, and preparing to enforce the ultimate, absolute solitude. To fully comprehend the physical weight of this isolation, you must understand that the universe is currently engaged in a massive, silent war of fundamental forces, and gravity is losing. On a local scale, gravity is a tyrannical force. It dictates the orbits of planets, ignites the cores of stars, and binds massive collections of matter together. But gravity is highly dependent on proximity. As the physical distance between objects increases, the strength of their gravitational attraction drops exponentially. Dark energy, however, does not care about proximity. It is a property of the vacuum itself. It is ubiquitous, relentless, and it scales with volume. Where gravity attempts to pull matter together into localized islands, dark energy seeks to push the very fabric of the ocean apart. And because the universe is overwhelmingly composed of empty space, dark energy has the ultimate mathematical advantage. Right now, our Milky Way galaxy is anchored by gravity to a small collection of neighboring structures known as the local group. This includes the Andromeda galaxy, the Triangulum galaxy, and a few dozen dwarf satellite galaxies. Within this specific localized pocket of space, gravity is still strong enough to overpower the repulsive expansion of the vacuum. We are gravitationally bound to Andromeda. In fact, we are falling toward it at over 100 kilometers per second. In approximately 4 billion years, long after our sun has scorched the Earth into a lifeless cinder, the Milky Way and Andromeda will collide in a catastrophic gravitational dance. They will tear through each other, their massive central black holes will eventually merge, and the resulting chaos will trigger a violent, blinding firestorm of new star formation. They will forge a single, massive, elliptical supergalaxy. This future supergalaxy will be our final impenetrable fortress against the dark. It will be a gravitational bunker holding out against the rising tide of the vacuum. Because outside the borders of our local group, the war is already over. Every other galaxy, every other cluster, every single structure in the visible universe beyond our immediate neighborhood is being swept away by the accelerating expansion. And they are not just fading into the distance. The mechanics of their disappearance involve a terrifying manipulation of time itself. As a distant galaxy is pushed closer to the cosmological event horizon, the space between us and it expands at near light speed. According to the laws of relativity, this extreme velocity begins to warp the flow of time. From our perspective on Earth, as we watch that galaxy approach the edge of the observable universe, we will see its internal clock begin to violently slow down. The orbits of its stars will appear to crawl. The detonation of its supernovae will stretch from weeks into centuries. The light it emits will be stretched into longer and longer wavelengths, dropping rapidly through the infrared, down into microwaves, and finally into ultra-low frequency radio waves. When the galaxy finally crosses the superluminal threshold, it does not simply vanish in a puff of smoke. It freezes. The last photons it emitted before crossing the horizon will be stretched to infinity. The galaxy will become a frozen, invisible ghost, a permanent fading imprint on the absolute edge of our reality. Over the next 100 billion years, every single galaxy outside our local group will undergo this process. They will all hit the boundary, freeze and fade into undetectable wavelengths. The sky will be meticulously, systematically wiped clean. This physical erasure leads to a consequence that is far more terrifying than mere darkness. It is the permanent deletion of cosmic history. Science is fundamentally built on the premise of observation. We understand the origins of the universe because we can look deep into the void and see the evidence. We can see the red-shifted light of fleeing galaxies, which proves the universe is expanding. We can point microwave antennas at the sky and detect the cosmic microwave background radiation, the literal thermal afterglow of the Big Bang itself. This faint static is the ultimate proof that our universe was once a microscopic, infinitely hot singularity. But as dark energy accelerates the expansion of space, it is actively stretching that evidence into oblivion. In 1 trillion years, the physical wavelength of the cosmic microwave background will be stretched so severely that a single wave of radiation will be larger than the entire observable universe. It will be completely impossible to detect by any physical instrument, no matter how advanced. The thermal footprint of creation will be erased from the crime scene. Simultaneously, the accelerating expansion will have pushed all other galaxies so far beyond the horizon that the night sky will be completely empty. There will be no fleeing galaxies left to measure, no redshift to calculate, no visual data to suggest that the universe is or ever was expanding. Imagine a civilization that rises from the ashes of a dying star within our merged supergalaxy 1 trillion years from now. Their scientists will be just as intelligent as ours. They will build magnificent telescopes and formulate flawless mathematics, but when they point their instruments into the dark, they will see absolutely nothing but the stars of their own local galaxy. They will look for the afterglow of a Big Bang, and they will find zero thermal evidence. They will look for the expansion of space, and they will measure a perfectly static void. Based entirely on the absolute best empirical evidence available to them, these future scientists will logically and flawlessly deduce that their single, isolated galaxy constitutes the entirety of reality. They will believe that the universe is static, unchanging, and infinite. They will believe exactly what humanity believed in the Dark Ages. The physics of the vacuum will enforce an inescapable epistemological trap. The ultimate consequence of dark energy is not just the physical isolation of matter, but the isolation of truth. The universe is actively burning the bridge to its own past. We are living in a temporary, privileged window of cosmic time where the evidence of creation is still faintly visible. We are the lucky few who get to know the truth before the universe permanently buries it in the dark. But the tragedy of the cosmos does not end with the loss of history. The darkness is not merely a geometric trick of expanding space. It is a profound thermodynamic destiny. The universe is an engine, and all engines eventually run out of fuel. The blazing stars that currently illuminate our local galaxy and the trillions of galaxies beyond are not eternal fixtures. They are finite mechanical furnaces performing a very specific temporary function. They are converting light elements, primarily hydrogen and helium, into heavier elements through the violent process of nuclear fusion. But this process is a one-way street. Once a star fuses its core into carbon, oxygen, or iron, that material is locked away. It becomes dead weight. The raw material required to build new stars, the vast clouds of interstellar hydrogen, is a finite resource. And the universe has already burned through the vast majority of its supply. Astrophysicists have measured the cosmic star formation rate across deep time, and the results are grim. The peak of cosmic star production occurred roughly 10 billion years ago, during an era known as cosmic noon. Since then, the birth rate of stars has plummeted by over 95%. The universe is no longer an active, thriving nursery. It is an aging population. We are living in the late autumn of the stelliferous era, the brief period in cosmic history where stars are allowed to shine. As the eons drag on, the remaining hydrogen will be consumed. The massive, brilliant blue stars, which burn their fuel with reckless intensity, will detonate into supernovae and vanish. The medium-sized yellow stars like our Sun will swell into red giants, incinerate their inner planets, and eventually collapse into dense, glowing embers known as white dwarfs. The only stars left will be the red dwarfs. These tiny, incredibly dense stars burn their fuel at a microscopic rate, hoarding their hydrogen for trillions of years. But even they are bound by the absolute laws of thermodynamics. Eventually, their fires will go out. When the last red dwarf exhausts its final atom of hydrogen, the universe will undergo a fundamental phase transition. It will enter the degenerate era. The cosmos will be littered entirely with stellar corpses. White dwarfs, neutron stars, and black holes will be the only physical structures left in the void. For a time, the white dwarfs will provide a pathetic residual glow. They are spheres of compressed carbon and oxygen, burning not with nuclear fusion, but merely radiating the trapped ambient heat of their violent past. But the vacuum is incredibly cold. Over unimaginably vast timescales, tens of quadrillions of years, these white dwarfs will slowly bleed their thermal energy into the expanding nothingness. Their temperatures will drop until they match the absolute zero of the surrounding void. They will crystallize into black dwarfs, silent, frozen, invisible spheres of degenerate matter, completely indistinguishable from the blackness that surrounds them. The neutron stars, The ultra-dense cores of collapsed giants will suffer the same fate, their furious magnetic fields dying away, their rotations slowing to a halt, turning into cold, dead iron spheres. The darkness of the night sky will transition from a trick of redshift into a literal physical reality. The engines of light will be completely dismantled. In this unfathomably distant future, the only objects holding any significant mass or energy will be the black holes. They will sit in the centers of dead galaxies, surrounded by a swirling graveyard of black dwarfs and frozen planets, silently waiting. But the ruthless mechanics of quantum physics dictate that even black holes cannot survive the deep time of the cosmos. Through a process theorized by Stephen Hawking, black holes slowly leak quantum radiation. They evaporate. The mathematics reveal a merciless truth. The smaller the black hole, the hotter it burns, accelerating its own evaporation into the void. Over timescales that require a 1 followed by 100 zeros to express, even the supermassive black holes that anchor the galaxies will bleed out, detonating in a final microscopic flash of gamma radiation before dissolving into perfectly empty space. This is the ultimate resolution to the paradox of the dark sky. The sky is dark because the universe is on a one-way trajectory toward absolute zero. The heat is being diluted, the light is being stretched, scattered, and physically exhausted. The darkness we see tonight is not merely the absence of light. It is a preview. It is the underlying default state of reality asserting itself. We are currently experiencing a temporary, violent thermodynamic anomaly, a brief, localized spark in an engine that is ultimately designed to cool down, break apart, and fade away. The void is not a backdrop against which the universe exists. The void is the destination. And as we map the accelerating expansion and calculate the finite fuel of the stars, we are forced to look at the cold equations and recognize the inescapable shadow they cast over everything we are. The dark night sky is perhaps the most profound and comforting optical illusion in human history. For millennia, we have looked up into the black expanse and seen peace. We saw a quiet, unchanging canopy, a static backdrop against which we could project our mythologies and plot our navigations. But the mechanical reality we have uncovered reveals a truth that is infinitely colder and far more hostile. The darkness is not a passive theater. It is a tombstone. It is the visual, physical evidence of a universe that is actively tearing its own architecture apart, outrunning its own light, and methodically exhausting its finite reserves of fuel. When you stand outside in the freezing air and look up at the isolated pinpricks of light, you are not looking at an eternal system. You are observing a temporary thermodynamic glitch. You are witnessing a fleeting, highly improbable moment of warmth and luminosity in a vast machine that is overwhelmingly designed for cold, silent entropy. The black, empty spaces between the constellations are not merely the absence of stars. They are the active physical manifestation of cosmic isolation. They are the expanding borders of an inescapable, mathematically enforced quarantine. Humanity has emerged in a staggeringly brief, privileged sliver of cosmic time. We arrived late enough in the timeline for the dying stars to have forged the heavy elements necessary to build our biology and our planet, yet early enough to still see the ancient light of distant galaxies before they are pushed permanently beyond the superluminal horizon. We are the momentary observers, stationed at the very edge of the abyss, watching the lights of reality go out one by one. There is no grand, underlying architecture designed for our comfort or our comprehension. The merciless equations of the cosmos do not care about human intuition. The geometric dilution of the inverse square law, the violent stretching of the Doppler shift, the relentless exponential acceleration of dark energy, these are blind, indifferent mechanisms. They are executing their functions with absolute unfeeling precision. They are actively stretching the ancient light of creation into invisible ghosts, freezing the fleeing galaxies in time and preparing to permanently dismantle the thermonuclear engines that briefly held the dark at bay. We spent centuries building massive, perfectly curved lenses and orbiting digital sensors to conquer the dark, desperately trying to fill the void with data and meaning. But the deeper we look, the more aggressively the universe asserts its terrifying scale and its ultimate destiny. It showed us a sky saturated with the blazing fires of 2 trillion galaxies, only for the brutal physics of the vacuum to instantly render them completely invisible. The universe is actively, relentlessly hiding its true face from us, stretching its own history into an undetectable phantom. The paradox of Heinrich Olbers is finally resolved, not with a comforting physical barrier or a geometric trick, but with a mathematical sentence of absolute, inescapable solitude. The dark sky is the encroaching shadow of the cosmological event horizon, closing its grip around our local island of matter. It is the slow, methodical, and completely unstoppable erasure of physical reality. The next time you step into the dead of night, do not look for the familiar shapes of the constellations. Do not look at the light. Look at the suffocating blackness behind them. Stare directly into the empty spaces. That absolute silence is not peaceful. It is the physical sound of the universe evaporating into the void. It is the shadow of absolute zero, a silent, infinite ocean of degenerate matter, patiently waiting for the very last fires to finally burn out. Description. The night sky is a mathematical impossibility. By all laws of basic geometry and infinite scale, the heavens should be an unbroken wall of blinding, lethal plasma. Yet, we look up into a freezing, silent void. This discrepancy, known as Olbers' paradox, is not a trick of perception or a shadow of interstellar dust. It is a fundamental glitch in the architecture of reality. The darkness is the physical manifestation of a universe that is actively tearing itself apart, outrunning its own light, and methodically isolating every structure within it. We are not looking at a peaceful void. We are watching the cosmos evaporate. If you enjoy what we do here, hit like and subscribe. It genuinely helps. Sources: A. Wikipedia, Olbers' paradox, https n wikipedia.org, wiki Olbers percent. 27 Paradox B. NASA Science, Hubble's Deep Fields, https science.nasa.gov, mission Hubble, Science, Universe, Uncovered, Hubble, Deep Fields, C. NASA Science. What is dark energy? https science.nasa.gov, dark energy.